Hello, everyone. This is our Purdue Indy 500 car model. Unfortunately, we don't have Semi with us, but we do have
Madeline.
Navi.
and Sid. As Purdue Engineering celebrates its 150th anniversary, the Dean's Office wants this milestone to be more than just a number. They want the legacy of Purdue Engineering to come alive for students and visitors. But right now, many of our campus displays look more like this: static. They're informative, sure, but they don't pull people in. There's no interaction, no immersion, and definitely no spark that makes someone stop and say, "Whoa, that's cool." And that's a missed opportunity because Purdue's engineering history is incredible. From early innovations like this to the modern breakthroughs we celebrate today, there's a rich story here, but the current displays just aren't telling it in a way people can connect with. So, the problem is simple. Without interactive microelectronics based exhibits, we're losing engagement. People walk past instead of leaning in, and that means fewer chances to celebrate Purdue's past and inspire the next generation of engineers.
Now we're going to show our top two design options and how we tested each prototype. The first design was the Purdue SRX car model. To test this design, we made a small version of a car and pushed it across smooth surfaces to measure how far it would travel. On average, it only moved around 6.5 inches, telling us that the axle design had too much friction and would definitely need a redesign if we moved forward with that idea. Our second design was the interactive, unfinished Purdue P block. For this prototype, we created a model inside the video game Minecraft. We used a we made a model using tripwires, redstone, and skulk sensors, and these items represent a gamified version of motion sensors and wiring. When these game version motion sensors would go off, the block would light up, creating a cool glowing display. To test engagement, we invited peers to see the Minecraft world, and they could interact with the model. We asked what their thoughts were on the model and the idea as a whole as they tripped the sensors, triggering the display. Finally, we compared both designs using a decision matrix. The car model got a score of 195 points, tying with the score of the Purdue P block. Both designs have their pros and cons, but we felt as a group that the car was a more fun and challenging concept and chose to go in that direction.
Here is the car we are modeling. A model of this car was made in Tinkercad and will be shown in the slide below. In 2023, Purdue partnered with SRX to put a Purdue and Indianapolis car into the race. This not only brought attention to Purdue and Purdue and Indianapolis, but also helped promote one of Purdue and Indianapolis programs, motorsports engineering. A scale of 20 to 1 was recommended. However, we believe this design will be best with a 10 to 1 scale because the car's approximate original dimensions were only 200 inches long, 76 inches wide, and 40 inches tall. Here is a model of the Tinkercad car. We decided to use this race car design because Professor Morphew already had code to make the car run and the wheels turn. This will save us lots of steps in the coding process later. Our car will have two motors in it and an axis connecting two wheels. The wheels will be turned by the motor, and this will allow the car to go forward. Participants will have a remote to take the car around a track in the shape of the Purdue Indianapolis 500.
So, for our data to support why we chose our final solution as the car, so firstly, this cost $3,750 to build estimate, and this is in fact not our cheapest model. However, this was definitely taken into consideration. Additionally, this was tied for our highest score on the weighted decision matrix at 195. Also, this would only require roughly 36 volts, which is over a safe threshold, which would be a max of 30 volts, but we can certainly lower that, and this will be addressed later in the limitations. Also, when we questioned 20 students in a survey for our three designs, we found that this was the highest rating at an 8 on the Likert scale, and also this would take roughly 2 hours to install. And for limitations, we definitely understand that this will be more expensive than the other two options. However, we are going to address this by choosing cheaper materials. Also, this would use more voltage than what would be a safe threshold at 30 volts. So we do want to make sure that this is safe, especially if there's poor weather. Thank you.